shifting the AEC Sandbox. We have 4 awesome speakers. We have Dimitrie Stefanescu, right? Did I say that right? Cool. Founder and CEO of Speckle. We have Wouter Riedijk. Did I say that right? I tried. We have Alex, I forgot to write your last name, CTO and co-founder of ShapeDiver, and Andrew Heumann, software developer at HYPAR. We have 5-minute presentations by these individuals, and then we'll kick it off with a Q&A session. So first off is Victor, and then HYPAR, and then ShapeDiver, and then Speckle. So in that order. Thank you.
Hi there. Can I use this for the presentation? Cool. Yeah, so my name is Wouter Riedijk, which is actually quite a difficult name for English-speaking people, so I don't argue with that. So I'm founder and CSO of VIKTOR, and big background in the industry, a serial entrepreneur. So I'm a maritime engineer by trade from 2012 with actually the current founding team. We founded 3 other companies combining tech, consultancy, engineering in the industry. And it's a big, long story for 5 minutes, so I won't go into detail. But from that time, we learned a lot about the needs in the industry, what we could really add to the industry. And therefore, we started VIKTOR in 2019. Yeah, and of course, I just was talking to Dimitrie. I want to congratulate you with your funding round. So congratulations. But he told me it was already done in March, so for him it's not new. But congrats, because it's very inspirational that you do this in this industry and shifting the AEC sandbox. But first, the challenge we all face. This probably is not something new for you, but we have a lot of CO2 emissions. And of course, or not of course, but the big thing is, of course, that the building industry is the biggest contributor to it. So we have a really big challenge there, especially if you combine it also with other challenges, like we need to build a lot or restore a lot, refurbish. For instance, in Europe, they are planning to build 25 million homes in 10 years. And then next to that, of course, in the infrastructure, also a lot of investments need to be done. It's getting older. You need to have more new infrastructure, but also rebuild it, replace it. And that takes a lot of investments as well. How do you do that all when, especially on top of that, we are also seeking for highly skilled engineers in this industry. Like 80% of AEC firms are actually struggling to find highly skilled people, engineers, within this industry. So all these combined is a big challenge. So what we think we have to do is we need to work smarter. And we really believe we can contribute to that, because we think we can. And how we do that with VIKTOR is we would really like to empower all engineers to create and share apps that automate your workflows effortlessly. So how do we do that? First of all, we make it really easy to create web applications. So for engineers with coding background, without coding background, all engineers, we would like to enable them to create web applications. These web applications, we make them fit seamlessly into your existing workflows with integrations to your existing software packages. And in that sense, collaborate with multidisciplinary teams in this environment, and also combining this data. So on top of that, we provide an environment for enterprises where all these apps are combined. So they can be found easily, they can be maintained easily, they can be shared easily. So this is a bit of VIKTOR. If you think that's interesting, please find out more at viktor.ai. Thank you.
So how does this work? Yes, excellent. Hi, I'm Andrew Heumann. For the last 5 years, I've worked as a software developer at HYPAR, and I'm super excited to be a part of this amazing panel and also show you a little bit of what we've been up to. So if you saw or used HYPAR before September, you probably know us as a web-based design platform with a heavy focus on intelligence, automation, and extensibility. Over the last 5 years, we've built out powerful infrastructure for collaborative modeling, automation, and simulation, with a great developer experience backed by an open source core. Over the last year and a half, we've redoubled our focus on one very specific user group, intelligent space planning. We talked to literally hundreds of users doing space planning across workplace, healthcare, data centers, retail, and lab planning, and discovered a common theme. When working with complex sets of program requirements, Revit can be too heavy and cumbersome at an early stage, and tools like Bluebeam and Miro are more fun and flexible, but not maybe precise or powerful enough. So there was an opportunity for a tailored intelligent space planning solution that's fun, fast, easy, and powerful. But there was just one problem. Our original UI was built for experts and developers. It was powerful, but we had to admit to ourselves that it was decidedly not fun, easy, and fast. So about a year ago, we decided to rework our UI from the ground up, all without sacrificing our powerful core. We released this new iteration of HYPAR at the beginning of September, and so far, designers and planners really love it. You can easily import your program requirements. You don't even have to follow a particular spreadsheet format. We'll interpret whatever format you're using and quickly get a set of smart planning blocks you can use to explore different design solutions with simple, intuitive gestures. As you play with different spatial arrangements, smart resizing makes sure that planned areas stay constant. As you add spaces from your program, you can keep track of what you've added and what's still missing automatically. You can toggle between diagrammatic and detailed displays so that clients don't get too distracted by too much detail. And at any time, it's easy to share a link, export a scaled PDF, or bring your model into Revit for further development. Let that play. But some people look at this and ask us, where's all the automation and AI? Where's all that powerful HYPAR goodness in this simple interface? And the answer is, it's coming. We just had to figure out the right way to integrate it that wouldn't overcomplicate things or get in the way of the simplicity and clarity that we've worked so hard to achieve. Our first venture in that direction is a new feature we're calling suggestions. Think of it like spatial autocomplete. You just start building your model, and HYPAR looks for opportunities to add detail or introduce new elements and systems. If you create a building, maybe HYPAR will suggest a basic structural grid. If you define a department and program requirements, we can give you a suggested departmental layout. If you label a space, you'll get suggested furniture and equipment layouts. It's pretty early days for this capability, and not everything is available quite yet, but we're really excited about the possibilities of this kind of ambient contextual automation integrated directly into the design environment. And lastly, we haven't forgotten about all our developers out there who want to build on top of HYPAR. We're not quite ready to release this, but because the core infrastructure of HYPAR is all still there, tools like our command line still work, letting you use our open source elements library to add custom elements, suggestions, or analyses. You can live edit code and see the results in real time in the HYPAR design environment, and then share your creations with your team or with the world. Best of all, you can sign up on HYPAR today and use it totally free for your first 3 projects. We'd love for you to share this with your colleagues who do space planning or blocking and stacking or early stage massing, and send us lots of feedback. Thank you.
Hi there. Hi, my name is Alex Schiftner. I'm not Matthias. Matthias actually got lost in London. His flight got cancelled yesterday evening, so I'm replacing him here to talk about ShapeDiver. And yeah, I'm just gonna give you a free speech mostly, and then walk you through the slides just to tell you a brief history of ShapeDiver. ShapeDiver nowadays is a fully managed Grasshopper backend. How did we get here? We founded it in the end of 2015. Interestingly, that's when I met Dimitrie for the first time. It was founded by me and two co-founders who are all applied mathematicians. We spent a year coding the first version of it, and then we entered the market immediately. And actually, we're selling it for e-commerce applications. So most of our initial customers, our first 4 years, completely funded by e-commerce. And it's still 50% of our business nowadays. Actually, in about in 2019, we got in touch with guys from TT, who then in 2020 invested in ShapeDiver by means of the twin investment vehicle. And from then on, we started focusing a bit more on AEC. So extending ShapeDiver by features that are important for computational designers in order to grow their impact within the companies. Actually, the very first version of ShapeDiver, when we started it, was still based on Rhino 5. Now we have Rhino 8. Back then, I think that there wasn't a business model at McNeil on how to run Rhino in the cloud. So maybe we triggered that. I'm not sure. So in the features that we focused on in the past years were to actually have to just take the risk out of running Grasshopper and Rhino in the cloud. So we offer a possibility to upload your Grasshopper models and turn them into REST APIs and into web applications. And you can stay fully within Grasshopper to do that. A feature that we focused on in the past year is called App Builder. So you might know a famous plugin by Andrew called Human UI. And well, App Builder is essentially the web-enabled version of this. So you can use Grasshopper to design and define the user interface of a 3D web application. You upload your Grasshopper model, and in the end, you get possibilities to embed them into your websites, into your e-commerce system, or stay within the platform in order to share them securely. What we also focused on in the past year was to enhance our support, enhance our APIs and SDKs. So it's very easy to plug that service into other software. And well, one of the latest connections we established was actually to Speckle. So you now can send data actually from Grasshopper running on ShapeDiver directly to Speckle. ShapeDiver is used to build e-commerce configurators in AEC. This example actually shows a configurator that's used to configure noise protection walls along highways. So it goes from very small examples to very big ones. All right, that's about it. Thank you.
I'm the guy who's going to fiddle with the presentation until it works. So, hello, I'm here to talk about Speckle. This is a very funny moment, I think. My name is Dimitrie Stefanescu. I'll tell you why this moment is funny for me. I'm the founder and CEO at Speckle. Together with Matteo, I started the company back in 2020. But why this moment is funny? I've been here 7 years ago. Okay. I have many slides. I can talk through these. So I was here 7 years ago. It was a very funny moment. It was the first time I actually saw Speckle as a logo somewhere. Like, it was really impressive in an event. And there's an extra layer of irony there. It's also quite close to the Autodesk logo. Like, I'm not sure that's going to happen much. in the future. Like a bit of the history of Speckle, 2015, I was lucky enough to get a European Union research project and basically be left alone to hack. Created Speckle as an open source little thing. Matteo was one of the first contributors. He added the Dynamo connector. Back then it was just a Grasshopper thing. Then somehow we annoyed each other enough that we started a company. We raised the pre-seed. Then we raised, things were going well, usage was happening. We raised the seed round. And then what people were talking about today, we've added a Series A right now to our funding history. And what did we add that money for is essentially to kind of build secretly the black part on this slide, the open source layer for the data inside AEC. Now, on top of this, usually infrastructure by itself is something non-sexy. We're very product-oriented people. We also built essentially 3 core value propositions on top of this infrastructure layer, centered around connectivity, collaboration, and automation. I'm gonna go really fast through these things. Actually, I have 3 minutes left. I can slow down. Connectivity is the old interoperability, the old problem of getting stuff from Revit into Rhino or the other way around. We're solving that to the best of our ability. And we're always focusing on meaningful workflows that essentially are daily drivers in some design processes. But we're going a bit beyond that. We're also, of course, trying to enrich data. So kind of, again, focus on workflows that save people time and headaches, hopefully. At the same time, it's not just about essential interoperability. It's also about making this data accessible. So business intelligence obviously cropped up quite soon. Speckle was a very technical product originally. It was catering to computational designers, but suddenly people realized that, hey, buildings are just data, I'm repeating some old mantras. But once you have that there, yeah, I see Andrew's laughing. I think we can talk about that later. Once people realize that, then they realize that, hey, they can take their Revit model, drop it in a PowerPoint presentation, even as an embedded 3D model in PowerPoint, or inside Power BI. And then these Power BI dashboards, then executives use them to talk with other executives, and so on and so forth. Now, collaboration, this is where we are looking towards the bright future promised by the web. So here we're building a lot of very exciting stuff. Again, everything you see here is open source. So these, you can take them either as a finished product, or you can take them as building blocks on which you can scaffold your own internal design innovation on top of. Multiplayer collaboration, this is like, yeah, same 3 people looking at one model in a browser together, doing design reviews with comments attached to that specific location, and so on and so forth. There's versioning and change tracking. This is something that's a bit more particular because secret sauce in air quotes, because nothing is really secret in Speckle land, where we can easily give you like diffs between 2 model versions. And all these things happen instantaneous. So we're trying to shift the paradigm away from clunky desktop software to the web, or to where it makes sense. Model federation, again, this is stuff that when we open Navisworks, it's very difficult for us to cope with what Navisworks gives us. And it's also very difficult for us to accept ultimately that the AEC industry is still de facto at that point in time. Of course, our powerful viewer, yada, yada. We've also added a layer of compute, essentially, on top of this stuff. So Speckle is not essentially just a data streaming platform. It's also a productivity platform, in a sense. Every time you send data to Speckle, we store it, but you can also consume it. So automations is a way for us to kind of bring the paradigm of continuous integration and development from doing very stupid things like checking if all your parameters are correct, or if all the fire rating of a door is in the right place, to essentially running CFD analysis and so on. So it's an agnostic backend where you can upload your Python scripts, in short, if you want. A bit like VIKTOR AI. And yes, clash detection. People love clash detection. This has been overall very successful in a sense. Like the industry is starting to look at us as kind of like the data hub. It's basically an open source bet on the future that Autodesk will not control all your data. And in terms of what's next, I have to shill out our conference in London. We're also organizing essentially a productive event that if you guys want to come, Matteo is ready to give you free discounts. So that's it. Thank you.
Awesome, awesome. Thank you, gentlemen. Cool. So definitely a lot of brain power here on the stage at this moment. So let's talk a little bit about, I mean, you each hinted a little bit about sort of the origins of, like your backgrounds and, the platforms and all. But let's dig into a little bit more about those origins and sort of try to talk about sort of what sparked the idea for the vision, whether you envision it as a company, whether you envision it as a platform, whether you envision it as a product. What was sort of that spark?
Since it was on my chair, shall I start? Yeah, so like I mentioned a little bit before we started VIKTOR, we had a few other companies. And what we really noticed, being an engineer in the industry, doing consultancy, a lot of the things engineers actually do, they are still quite repetitive, not very integrated. That was also counting for us. And when we added tech to that, we noticed that really to unlock the engineers' potential, you could really make engineers themselves automate their own workflows. So we did that first for ourselves. And that really sparked that we thought, okay, this is really the thing that could help engineers around the world being more productive and focus on the real intellectual fulfillment. What you have as an engineer is solving those solutions. So that's also where our credo comes from: automate the boring, engineer the awesome. Making engineers automate their workflows themselves and really empowers the engineers and the engineer companies to take the next step. So we found it out in the early days when we were doing this in the industry as entrepreneurs. And what we really noticed, and that's also where our name comes from, VIKTOR, is actually from victory, is that the companies that embrace this could really make a difference in the industry. So that's a bit it.
Cool.
For us, very different story. Actually, me and my co-founders, we were working in a geometry consultancy company called Evolute, where we were consulting architects, structural engineers, facade contractors. And at some point, we came across a customer who was not from that industry, but from actually additive manufacturing. Or rather had the idea to build a 3D printing platform. And that's when that sparked the idea of actually taking Grasshopper to the cloud in 2015. And we just did it. So we didn't, our founding of ShapeDiver was not actually motivated by the AEC industry. It was essentially solving a problem and finding the customer later. And once we had the customer, we were following the essentially we were really focusing on what's needed to solve their problems in e-commerce and later in the AEC industry. Yeah.
I guess it's my turn. I was very frustrated as an architect. I knew how to code Grasshopper scripts and so on and so forth, C#, everything, you name it. But I found that like my impact is very limited, and these limitations mostly come from essentially like the raw source material. The gold that I had to operate is locked into proprietary file formats. And all these things make everything very clunky, very slow, and also caused me to work 2 weeks on the wrong structural engineering plans and then basically throw out 2 weeks of work. So I've also discovered that it's actually a communication problem because of all these technical limitations, whether they're valid or not, that's a different discussion. But essentially, this communication problem is what kind of motivated me to start Speckle as a way to like lubricate the whole information flow of AEC.
I mean, the person who should answer this question is Ian, who's sitting in the front row, who founded HYPAR, but I'm gonna take a stab anyway. I mean, I think, Ian wrote Dynamo. Anthony, the other founder, came from Autodesk and been working on generative design. And I think so there's a deep embeddedness in this community, specifically in the community that was sort of involved in computational design, scripting, automation, tool building and stuff. But I think there was a level of frustration or disillusionment with the kind of actual realized gains from that kind of work, where there was this vision early on in the kind of computational design world that like we would build all these incredibly powerful tools and we would share them as an industry and they would, you know, improve all of our workflows. And instead what started to happen was just everybody was rebuilding all of the same scripts. Yeah, you know, every firm has their stadium bowl generator and every firm has their, you know, has their facade pattern, tooling, whatever. And so I think a big motivation for HYPAR early on was to kind of find ways for computation in sort of in a mirror image. If data is the sort of lingua franca of this, in from Speckle's standpoint, for us, sort of computation was that lingua franca, like finding ways to have a kind of a common computational language to talk about buildings, both through the kind of open source elements library, but also building a platform where you could just, you know, similar to VIKTOR, similar to ShapeDiver, where you could execute these things in a common way and hook those tools together. So I'm sure there's more to the story than that, but that's a short version.
Maybe next year we'll have you in on that. Yeah. Keeping on the topic of origins, it seems like most of you are kind of like in your second career, third career, maybe even more. And since you said you're on the serial entrepreneurial side, what wrong turn did you make to get yourself here?
I have a whole panel about that later, so I'm going to skip answering this.
Yeah, so that's a good question. So for me personally, what happened is I was, let's say, in maritime engineering, and I was really like really amazed by the fact that our study material was still almost typed out, and it was a very conservative industry. And I started working at different companies during my study to find out what it actually is, the industry. So I worked as a maritime engineer at offshore companies. And I was really amazed by the fact that how conservative things are going in the industry. And I really didn't feel that I would be happy if I would be working as an engineer at the end. So I really wanted to do something else, actually. So maybe I'm not that of an engineer in the end. So when at the end of my studies, I just thought, okay, I'm going to do something else than being an engineer and try to do something differently in the engineering industry. I'm not sure if it's a wrong turn because I really like it, but it was a turn.
Yeah, where did I go wrong? Yeah, essentially.
We don't have all day.
Yeah, you know, I started applied math. Maybe I did go wrong in the beginning of that. Right? So before I started applied math, actually, I was working in a software company that does software for dispatching orders to taxis, right? And maybe you make the connection because dispatching computation jobs to grasshopper workers isn't that different from dispatching orders to taxis. So, okay, that's just one connection. But essentially, when I finished my studies in applied math, I was working with, I was doing my thesis with Helmut Portmann, and then a lot of my colleagues were actually going to management consultancy or some insurances or so, and I just couldn't see myself there. Yeah, but the architecture really fascinated me, and being able to contribute there and see what results after a few years, but be able to see it. So that's how I got into geometry for architecture, and then later into ShapeDiver. Yeah.
Yeah, fascinating. I was very curious to hear this answer, actually. I mean, there's an indirect cause, like the economy took a downturn when I graduated from TU Delft. So basically, Zaha ignored my CV. So you did UN Studio. My portfolio was not, you know, double curve things were not hot anymore. So basically, then I realized that actually with my skills as a computational designer, I was falling flat in the industry building square things with bricks. I realized that kind of the tools that I had and kind of the creativity that I geared myself towards was not having a big impact, not much of it at least, right? So this is when essentially that wrong turn essentially got me thinking, what can we do more and better?
Interesting.
Can I ask a personal question in between?
Sure.
Because during the when we prepped it, you also mentioned something about. I asked you, you want to be an architect, and you mentioned something else. Is it something maybe also nice to hear for everybody, or?
Yeah, I mean, my retirement plan is maybe start an architecture office. Right.
Yeah. Usually you want to work.
Retirement. It's a hobby.
Usually you want to work less, not more. Anyway. But you know, in sort of this discussion, each of you have talked about sort of, you know, a sort of something that was missing, or this sort of false image that we, and I kind of had it too. You know, when you're in school and you finish your education and you come out into the real world and you're like, well, this is kind of crap. So so you try to, you know, carve your own path and so on. But, you know, talking about, you know, now the AEC on technology space and how you're like deeply rooted in it, what do you think is broken in the AEC industry, and why is the big tech in our industry broken? And this is not being recorded, right? Oh, and broadcast, okay.
I mean, this is such a hard question. But I think, like, you know, on the one hand, I love to look back over, you know, over the last, whatever, 12 years of this event and of the kind of, you know, since I graduated, the way that the computational design has sort of evolved. But I feel like upon reflection, there is a disconnect between the kind of vision that we were sold of an increasingly improving built environment where everything would be optimized and automated with you know, massive environmental improvements and analysis baked into every design. And the reality that I've found, and I think still find in the industry, is that a lot of times, you know, we manage to solve really interesting problems of our own making from the standpoint of geometry, of fabrication, things like that. I don't actually, I mean, there are obviously counterexamples, but I feel like at a kind of industry-wide level, things haven't changed that much. Like maybe the tools that we use are fancier and shinier in various ways, but I feel like the systematic change to our built output just doesn't seem to be there. And I don't think that's exclusively a software problem, but I also think that software has failed to live up to the hopes that I think kind of we had at the, you know, 10, 12, 15, 20 years ago.
I don't totally agree. No, let's say in the past 5 years, well, I agree for the bit that we are in an industry where there's a lot of time material, a lot of projects which are running for a long time, a lot of risk averse, and it's very hard to cope with that, right? I mean, we are graduated engineers, we are very smart people in the sense that we can make our own systems that actually create a lot of solutions. And what do we end up doing on a project? Using some Excel sheets and making 2D drawings and all those kind of stuff. And it really is a dynamic in the industry. It's hard to break because you need to do upfront investments to make automating work for your project, right? So that's a hard thing to cope with, but I see real change, right? I mean, what we are seeing now is that we have automation engineers at our customers who are full-time as an engineer making automation tools, right? Whereas 5 years ago, when we started talking to these companies, talking about VIKTOR, they said, okay, but this is not for us. We can't do it. This is not. And now every engineer coming from the university already knows a bit of Python and can really put it into the project and make a lot more, let's say, value. And also, if you see the, let's say, for instance, a big engineering firm, Arcadis, has a director of citizen development, right? So this was also a title which didn't exist 5 years ago, right? So there is change, but of course, the dynamics of this industry is pretty slow.
Yeah, well, from a mathematician's point of view, we're trying to solve global problems with local optimization, and that doesn't work. Maybe that's something to think about. Like, but it's not something that can be solved by computational design alone, I guess, because the way companies collaborate with each other just need to change, right? Or how we make contracts and how we talk to each other, and how do we agree also as a society on what's actually the global optimum. Yeah, it's really a bigger problem, I think. Yeah.
Yes, I mean, I have some very obvious political answers as well. Like there's monopolies around, maybe you've heard of them, maybe you're not. But to add to like kind of what have been said, I think, yeah, there's, like, I really appreciate it. It's a very thoughtful answer. I feel that there's also has been a lot of kind of, we see, there's one example I'll give from Speckle. There's like, I think 3 or 4 or maybe 5 embedded carbon calculators built on top of Speckle. And like, I don't know what to think about that. On one hand, it's local solutions optimizing for one thing. At the same time, it's also, for me, it's an extremely encouraging sign of the amount of like creativity, ideations, you know, and energy that exists in this room and outside of it. So I believe the way how that will converge, I think it's still a mystery to me. We're trying to make it converge. We're trying to provide that open data layer so that, you know, things at least work on the same groove. But yeah.
Yeah, I'll try to make it a little more optimistic now. I'll ask one more question, and then we'll open it up to the audience. Clearly, you know, we talked about the failures of the industry, and sort of even, you know, we had a brief intro call. You talked about the failures of computational design in a way, or computational designers, and sort of, you know, that foresight of we thought we could make, you know, this huge change, and these tools can make a change in our industry and so on. So how do you and your platforms fulfill, you know, making this change, you know, are for fulfilling that gap that you see? Do you think that your platforms are changing sort of these deeply rooted ways of our industry working?
I think yes, absolutely. So in a sense, in 2 ways, at least, this is what we're trying at Speckle. Like, first way is, okay, we're enabling a lingua franca of sorts. If you agree with it, fine. If you don't, you can modify it, by the way. And second is politically, like the political angle of being open source and essentially like putting control back in your hands is, I think, another key aspect through which we as a company and as a project, we're trying to push forward. And actually, I just want to give a shout out to Jonathan, because he embedded the failure of computational design in my head.
Yeah, so at ShapeDiver, we in the end we empower computational designers to do more, to get their knowledge, make it applicable by others who don't know about that. So in that sense, I think we are contributing to it. Will Grasshopper on the cloud solve all our problems? Certainly not, I guess, but it's a significant contribution.
Yes, of course. I think everybody's going to say yes, of course. No, but yeah, I think engineers are, let's say, not software developers. And what we are trying to do, of course, is giving them the tools to be able to do so. And we see it also as a team, right? So there's engineers working on projects with very little time to automate, with little skills, and engineers who have, let's say, in-depth Python knowledge, for instance, and can do that full time. And we like to cater for both, because we think if you do that, they can be as a team creating very valuable things on projects. And what we also see is that it's getting into upskilling programs of our customers as well, right? So what we saw, for instance, is a very big thank you from somebody who said, okay, I'm now actually learning Python by the use of VIKTOR. And he started off with the Excel converter, no coding knowledge needed. But on top of that, he started learning more and more and more. And I think, yeah, it is not a very fast change, but what we try to contribute is to really empower all these engineers to unlock this potential of kind of self workflow automation. So yeah.
We're not. No, I mean, no. So I think I would say we're not yet. I think that in order for the kind of power of automation analysis, you know, steering towards smarter design solutions through computation. I think it's really important that that not be a kind of a separate place that you go, a separate world. You go over to analysis world to go figure out how things are going. I mean, I really appreciate the NTOP presentation earlier for the way in which sort of simulation is deeply embedded into the design environment. And obviously, you know, we don't have a ton to show for that yet. I think actually past HYPAR had more of that to show as we're in this kind of transitional moment. But I'm really bullish about the kind of small influence we can exert through concepts like suggestions. This idea that we get to exert a little bit of pressure on how suggestions get surfaced to you, how design suggestions get surfaced to you. And it's been very important to us as a company from the beginning that we should make a piece of software that makes it easy to make the right building decision, easy to make the right building, and maybe even hard to make the wrong one. If, you know, there's software out there that makes it really easy to do huge swaths of surface parking that shall not be named. And I think like we don't necessarily want to do that. I mean, you know, we also maybe don't want to prevent you from being able to do that, but I think there's room for automation to be, you know, every piece of software is going to exert a little bit of influence on the work that comes out of it. And so I think we have a commitment to being responsible with that influence.
Makes sense. Along with the bowl configurator, there's ample parking
Yeah.
configurators.
Yeah.
Any questions from the audience? Yes, we got one right here.
Hi, can we chat for a second about open source in AEC? And why did you choose or didn't you choose to open source your apps? And also, how did you manage to protect your intellectual property, especially at the beginning as a tiny company?
I mean, I can say briefly, we have kind of, you know, our interface, which is not open source, and our core library for BIM representation and geometric operations, which is open source. And I think, you know, again, probably an Ian question since he was the one who made this decision, but I think, you know, for us, it just seemed like the right thing to do, but it also has a couple practical benefits. One of them is that like people adopting a new platform worry a lot about lock-in, worry a lot about getting somewhere and then discovering that, you know, the company that I've just been doing all my projects in for the last 3 years is gonna go away and all of my stuff is going to be lost. And so the notion that models can come out, the notion that even the work that you do building the script, even the work that you do to contribute your custom logic or your simulation tools or your automations isn't dead if the platform that it was designed for goes away, I think is actually a really compelling argument in favor of open source, so that the data and even the thinking can kind of migrate and move from platform to platform if it ever needs to. And we've also seen some benefits from that. You know, folks are building Revit plugins using the Elements library, and they don't even need to talk to us or pay us a dime, but they contribute back, you know, improvements and things like that as well.
Thanks. Yeah. So for us, I think it's a bit pragmatic. First of all, it was not really considered. So we build our software development kit for security reasons and stuff like that. It's not open source. And we try to cater for, so we have a free version. You are able to make an application, host it in the cloud without paying. So you're really serving the people who would like to do stuff for free, right? And we didn't expect too much of, let's say, the contribution side yet, because in reality, what you see is that it often is still that you have to maintain everything mainly yourself. We are actually, we want to make it open source, our SDK, but it's not on the top of the list of our roadmap, actually. So that's very, let's say, pragmatic. We want to build a lot of other stuff first, and it's not on the top list because we don't think it makes that of a difference for our community.
So for us, we didn't consider in the beginning open sourcing it, but in the past years, as we have improved our software development practices, improved the code standards and so on, we started actually to open source quite a lot of components that we developed. For example, this app builder component I mentioned, it's for the open source, the front end part of it, and the rest is just a small Grasshopper plugin. But so we decided, depending on the component, to open source certain parts, also our SDKs. I think, honestly, nowadays, if you would open source all of our software, it wouldn't disrupt our business. We might even do it at some point.
Mm-hmm.
Yeah. So I think what's also related to the open source question is the question of where to run it and how to run it on the cloud. Because that's, as soon as you need to, as you're providing a cloud service, and I think it's also relating to Speckle Automate, right? It gets much more difficult, right? So the open source software can be there, but then actually running it, that's a different kind of story, right?
Yeah, there's a clear distinction between the distribution and mechanisms. In a sense, for Speckle, it's a twofold answer. In a sense, first off, at the beginning, Speckle had to coexist with this thing called Flux, if the old timers here remember it.
What was that again?
Flux. Yeah, we're getting old, guys. I think. Sorry. And this thing called Flux raised, I think, like 4 times more money than we have raised to date.
29 and change.
29 and change. Okay, there you go. So, and it was a very kind of, and one of the feedback that I was getting, like I almost killed Speckle as a PhD research project because I said I'm going to use Flux's thing and like do my communication, with it. But the feedback I was getting and like my own personal feedback was like, it was not open enough, right? And gradually our understanding of how open source works ultimately boils down to a quote from the tech industry, which is like, if you build infrastructure, it has to be open source. And this was the level of my ambition to where I wanted to take Speckle. And Speckle is open source. There's a side answer, which, public money funding public research, public outputs. But that's maybe a very European standpoint. But yeah, ultimately, it was inherently tied to our mission and kind of the impact that we wanted to have on the industry. And it's literally putting our heart on the table saying, yeah, you can keep us accountable.
A short follow-up question. There's a history of open source software being taken by Amazon and turned into a paid service. And then essentially the open source project is dead, right? Or kind of. How do you address that?
Easily. There's a similar history. It's a continuous evolution. So one here, AEC is miles behind this kind of problems at the time now. But there's a similar history evolving right now. And I think here the story of Elasticsearch, which is maybe some of you guys have used now and then, like because of that specific reason, it went source available. So it didn't prevent essentially the usage inside companies and so on. It basically said, Amazon, you can't resell us, right? But recently, I think like 3 months ago, they enabled a fruitful partnership with said cloud provider, and they're back to open source. So essentially, it's a continuous evolution of the industry realizing it can cannibalize itself up to a point. So yeah, it's I think this is a space where new ground is being broken, actually, in terms of the models, the kind of like the financing of said companies and so on.
Cool. Any other questions?
Thank you everyone for the wonderful presentation. So as a computational designer in-house, like we think the problem is more regional, like more project basis, like you have a problem, like we try to solve that problem. The thing we always wonder about, like the designers always get overwhelmed with new technologies. And what should be the solution in this case? Like, should we be like fixing the small problems in the existing infrastructure, or like should we push everyone to grab a new platform which is evolving? So that's like always a confusing thing happens, and like what should be the balance for that?
That's a very good question. I have one very good answer. Human UI too, I think, needs to happen. Sorry, that's a bit tongue-in-cheek, but I think it's a very good question. I think this is a responsibility that we have as well. Like Speckle's core, let's say, target group has shifted over time from purely computational designers such as yourself to essentially us realizing now, you know, there's people like my dad, who's a 67-year-old architect using Speckle from SketchUp and so on, and trying to whip out a Power BI dashboard. That takes a completely different set of kind of products that you need to build. And I think I've loved seeing HYPAR moving in that direction to a certain extent. And we as Speckle were again trying to reduce that complexity so that it just becomes something you just pick up. I won't answer for Alex, but I have an answer for Alex as well. So.
Well, I think it's very specific to whatever you are working on, right? I can't give you a general answer to your question, I think, because I can see that there's so many influence factors that lead to the choice of the right tool. Yeah.
Yeah, it's a good question, and I think it's of course overwhelming. You also see that, but that companies and everybody is overwhelmed by the new technology, of course, and it's in that sense also their, I think, responsibility to make it available within the company that you can test new technologies, that you have some time available, because in the end, the investment you spend in, let's say, kind of research and discovery upfront will pay out in the end at a project, right? So I think it would be wise for companies to have such, let's say, processes that you can discover as an engineer or computational designer, the newest technology once in a while to make sure that you end up with the right solution. That would be my answer. And of course, tapping into each other, right? So don't make silos any longer, but make sure that we stay communicated and open as technologies in the future.
As a software company that's building stuff that's sort of, I don't know, perceived as cutting edge, we encounter two very different user groups in the teams that we talk to. We encounter the sort of like cutting edge computational designers who are super eager to jump on and try new things and see how these things work. And then we also encounter the sort of non-computational design groups that are even within the same firm who are just trying to get their job done. And I think it's actually important for both of these roles to exist and kind of balance each other out. I think it's important for there to be people who are investing a little bit of energy in kind of exploring new tools. I also think the failure mode of that is chasing the shiny thing at the expense of any real impact. I think it's really easy to fall into a trap of, oh, now I'm going to use AI for X, and now I'm going to use this for that, and not connecting it back to real value for design teams on the ground. So that's the risk. But the sort of mirror image risk on the other side is getting stuck in old ways and getting, you know, relegating yourself to just always doing things the same way. And I do think a lot of firms fall into that trap too, of just, this is how it's always worked. This is just what we're going to do. We're not even going to explore the possibility that something better might come around. And I think there are also a lot of like infrastructures, especially in larger firms, that get built up that have this kind of calcifying effect, that kind of build a lot of process, that well-intentioned process to say like, you know, let's not just adopt new tools, but that also introduces maybe sometimes unnecessary friction towards trying out new things on a particular project. Oh, it's got to go through, you know, this person who's got to check with that person, who's got to get approval, who's got to run a little study, who's got to do this. We run into this a lot too. It's like, no, you could just download it and start using it. Like that would be fine with us. I don't know about, you know, your boss or whatever. So that's sort of a non-answer, I guess, to your question. But I do think that these forces are never going to go away, and it's important for there to be people on both sides of that tug of war.
We have time for one more question, Pierce.
Hi, I'm just wondering what each of you thinks is kind of the sweet spot for automation, like where you're aiming to, like in terms of kind of a human in the middle. Like on one end, there's like spell check. On the other end, there's respond to all my emails for me. You know, but for your products, of course. So I'm just curious where you think that sweet spot is. Like, what's too much automation? What's like, yeah.
I have changed my opinion on this over the years quite a lot. I used to be very pro macro automation, and I have swung very far on the side of micro automation. I think that the challenges with macro automation, even a highly thought out, I'm going to sit here and I'm going to build this amazing analysis grasshopper tool that's going to account for every possible condition, and I'm going to hand it to my designers. It's just too fragile. It's going to break. It's not going to account for the flexibility that your team is really going to need. That I saw that story time and time and time again. And I think that there's enormous benefit in, the video went by too fast, but flashing on little tiny features, things like, oh, when I'm dragging this corner, this other corner knows to stay anchored. Like, you might not even think of that as automation, but in a way it is. It's just a little piece of algorithmic logic that makes a little decision on your behalf. And if it's the wrong decision, it's low cost. I think that's the other thing, is that like micro automations don't have to be perfect and don't have to incorporate every imaginable parameter. I get a little bit of heartburn when I see the screen of 9,000 sliders. And I think that like that way of working is like, feels really cool because it's like, look at all the power. But in real practice, it often winds up being incredibly limiting.
I can really relate to the story. Nice. Yeah. So what I'd like to add is, let's say, sometimes we forget that it's also about usability and adoption, kind of change management, actually. So a lot of customers dive into their dream automation, right? So they want to automate the whole stuff. But in the end, it's also need to be scalable to a wider audience, which need to change maybe from using Excel sheets and scripts to a fully fledged web application which can do everything. So then it really helps to chunk it to smaller pieces to make sure that you really know your user who's going to use it and learn from it before diving into further and further and further automation. And next to that, there's also this black box fear, which is very real, of course, for an engineer. An engineer in the end needs to give the stamp as well, right? So it needs to cross-check everything. So in that sense, also automation needs to keep in mind that it always needs to be a kind of engineering automation with an end result that's traceable for them. And of course, then when you get to more generative and AI stuff, that's gets a challenge, but that's also the power. It will be a mix in the end. But our advice would be to start small and not to jump into the biggest one.
Yeah, I can very much relate to what you said, Wouter, and you, Andrew. What I can contribute here is maybe from the e-commerce side of our business, where there's research, and it's really important to choose what the end user gets to choose, right? To choose that right, because you can create a lot of confusion by too much choice in the end. What I see might happen in terms of AI is that we use AI to essentially allow to explore the design spaces better and do certain optimization there. So I can see that happening.
Yeah, we have a very biased opinion. When we launched our kind of like our compute layer on top of Speckle data, we thought like, what is the span of automations that you can run, right? And then bringing back a metaphor to, let's say, Techland, very simple rules produce a lot of value. So how we're thinking it is like, there's a lot of low-hanging, boring automation that you can do. Basically, it's like, where do you spend time, or where are the costly mistakes? Can that be automated? Yes. And then surprisingly, from discussions with our customers and our users, a lot of that time is the fire rating of that door matching the fire rating of the wall it's in. It's a bit of a sad answer. It doesn't require any AI. But we're probably, I don't know, reflecting more where the industry currently is. There's obviously endless AI applications that you can build once you have that data. But that's, I think, something we are investigating. We still have yet to have come across a very specific and well-honed use case that is generic to a company, right? Like, I loved Andrew's examples. Those are like good examples of how AI is applied. But when you come to like large AI enterprise, they say, oh yeah, we want to put all our Revit models into a database and run AI on them. And it's like, why? Silence.
Because we can.
Maybe because you inspire me to tell, let's say, one story in that sense. For you can do very far automation, but which is very simple for the end user. For instance, we have a customer that built, let's say, an automatic drawing checker. So there was a very complex machine learning, which was trained on base of a lot of drawings. But for the end user, it's only uploading 100 drawings and getting back all the drawings with the possible mistakes, with the chance of that it is really a mistake, right? So that is a very simple tool in that sense, but there's very big automation kind of technology behind it.
Cool. Thank you. I'd like to invite the audience in thanking our panelists. Thank you.